Hello, in this video I introduce a little bit about subdivision. And subdivision is a very important and flexible theme in 3D. And I have here my program. This is a Tripscode in C language. And what we see here is a cube that has curves applied in front of back, and then it is applied the weights for curves, and then it looks like a cylinder, cylindrical. And how is this achieved? This is the theme of this video, and I wish to show a few drawings to this theme, because we don't wish to cover only the four sided patches or polygons. We wish to cover all sorts of polygons, for instance 5-sided pentagons, 6-sided, and they all need to be able to evaluate those polypoints inside those patches. We see here in front is also a cube, but with subdivision it looks like a sphere. And this is Catmull subdivision, but the idea is that we mix these new patches into the subdivision, then we manipulate those points into the new shapes. And I show a few drawings to illustrate the theme. In my program I made a very big efforts, and I came up with solutions for subdivision levels 0 and 1. Subdivision level -1 is essentially the base cage, but when the cage is subdivided, then we come up with more subdivision levels. And those drawings are really about how to organize those patches. Inside my program I have only this central point that has this patch flag inside a vertex object, and also polygons have those patches flags and edges also. But when a patch is created, then the information is along the edges. If this edge belongs to a curve, then he has a special shape and special procedure for those points that lie on the edge. But we need to come out with the positions also inside the patch for the rest of the points. And important thing to note, this is a 5-sided patch that is drawn out here partially, but if we look at those points, then every point inside the patch has 4 edges connected to it, except this central vertex. This has an option to have a different number of edge connections to it. And this is an important conclusion that we can make for every sort of patches. And what about this 4 directions that the rest of the points are object to? We can then create a patch object that uses this feature of those patches. And I have not made it in my program, but I speak about the idea that when we have more subdivision levels, then how to navigate inside those patches. And for instance, we could create bands that go along. I grab better way to point out those. those bands of we see here a band that is, and we make a system that assigns those bands to this edge. To this edge, those bands are then assigned. When the next subdivision level happens, then those are even more dense. And then they are numbered inside this batch object for this edge. And they find their coordinates for, I have drawn those little line segments here and here on the both sides. Here the curve is present in this direction. It may be present, it may not be present. When it's absent, then another algorithm takes over, and maybe it is something else. But if a curve is present, then those vertices here inside the band get their positions evaluated based on this curve segment and the other side, this curve segment. And when we need to be able to create a system that addresses those curve segments for every point. And that's essentially how those batches need to be set up. And what about this central point? Here I also have a previous drawing for it. And this point is when patch is applied, then it doesn't change its coordinates with next subdivision level. It is like a tip of the dome, and those reaps that emanate from this tip then end up in this immovable point. When the rest of the points maybe are evaluated, then they, with the next subdivision level, they maybe could move, or for some of the points. Depends on if it's patches or if it's Catmull. When we see this Catmull variant, then we know that those central points also don't move, but they are essentially the gauge points, and the rest of the points, edge vertices and corner vertices, then they get new positions, and this way we get this Catmull-Clark subdivision. But with patches, with first subdivision, this central point gets a new coordinate, and with the next subdivision level, this coordinate remains the same. But the shape of the rest of the points needs to be then calculated.